Hey everyone, welcome back to Roborequest. You ask, we build. Each month, we bring your creative ideas to life with an exciting robotics project. And this time, we have got something truly useful, a height measurement tool using an LCD display. This project is inspired by an awesome request from I2C who suggested making a height indicator using an ultrasonic sensor and LCD. Big thanks for your great idea. Keep your request coming, and who's know, your idea might be our next build. By the end of this video, we'll able to measure height accurately and display the result on an LCD screen. Now let's get into it. One HC-SR04 Ultrasonic Sensor to measure the height, one 16x2 LCD display with I2C module to display the height, some jumper wires, one USB cable to upload the code, one double battery holder and two lithium-ion batteries. Now in our previous height measurement tool project, we displayed the height reading on the serial monitor, but in this video, we will take it step further by showcasing the readings on an LCD display. Let's start by connecting the I2C module to the LCD display. The I2C module has 4 pins, GND, VCC, SDA and SCL. Now take some male to female jumper wires and connect them as follows. Take the Arduino board. First connect the GND pin of the I2C module to the GND pin of the Arduino. Next connect the VCC pin to the 5V pin of the Arduino. And then connect the SDA pin to the SDA of Arduino. And finally connect the SCL to the SCL pin of the Arduino. Now we'll connect the ultrasonic sensor to the Arduino. Take male to female jumper wires. Connect the VCC pin of the sensor to the 5V pin on the Arduino. Connect the GND pin of the sensor to the GND pin on the Arduino. Connect the trig pin of the sensor to digital pin 9 on the Arduino. Connect the echo pin of the sensor to digital pin 10 on the Arduino. Make sure to double check your connection with the circuit diagram. Now our circuit is ready, we need to add the code. Download the code and library files given in the description below. Open the code file if you have already downloaded the Arduino IDE, otherwise download the Arduino IDE first. The first thing we need to do is to include the necessary libraries. We are using the ware.h library for I2C communication with the LCD and the liquid crystal _I2C.h library to control the LCD easily. Next, let's define the pins for the ultrasonic sensor and set the LCD addresses. The sensor height is set to 30 cm, which means the sensor is mounted 30 cm above the surface. Trig _pin sends an ultrasonic pulse. Echo _pin receives the reflected signal. Sensor _height is the fixed height where we have mounted the sensor. The LCD is initialized with the I2C address 0x27 and configured to have 16 columns and 2 rows. In the setup function, we initialize the serial monitor, configure the pin modes and set up the LCD display with a welcome message. Serial.begin 9600 opens the serial monitoring for debugging. Pin mode trig pin, output function sets the trigger pin as an output. Pin mode echo pin, input function sets the echo pin as an input. The LCD is initialized and the height meter is displayed as a startup message. Now let's write the code that continuously measures the height and display it on the LCD. We first clear any previous signal by setting the trig _pin to low. Then we send a high signal for 10 microseconds, which triggers the ultrasonic pulse. Now we need to measure the time it takes for the pulse to return and convert it into the distance. The pulse in function measures the time taken for the sound wave to return. We convert the time into distance using this formula. Here, 0.034 cm per microsecond is the speed of sound in air. Since we want to measure height, we subtract the measured distance from the fixed sensor _height. Now let's print the height value on the serial monitor and LCD display. Serial.print function shows real-time height reading in the serial monitor. LCD.clear clears the display before updating new values. LCD.print function prints the measured height on the LCD. This loop runs continuously, updating the height measurement every 500 milliseconds. And that's it. The previous project measured the distance between the sensor and the object, while this project calculates the height of an object by subtracting the measured distance from a fixed sensor height. Distance measurement code use this formula. Height measurement code use this additional step. This ensures that we get the actual height of the object instead of just the distance from the sensor. In the distance measurement project, the LCD displayed distance in centimeter and inches, but in this project it only displayed height in centimeter. Now it's a task for you guys to show the height in other units as well, like millimeters and inches. Now upload your code to the Arduino. Connect the Arduino Uno to your computer using the USB cable, then select port and board in the same menu and select Arduino Uno. Now upload the code by clicking the upload button. And now with everything connected and code uploaded, make sure to mount the ultrasonic sensor at a fixed height as mentioned in the code. In our code, the height was set to 30 cm. Now stand an object below the sensor and check the displayed height. The height should change accurately as you move the object. I hope you found this tutorial helpful. Don't forget to like, share and subscribe Roboarmy channel. Thanks for watching our tutorial.